Okay, next alkaloid we will start with biosynthesis of cinchonine and quinidine. Okay, so it's we are now shifting from the indole type alkaloids, the alkaloids which involves the indole moiety. From that one, we will now shift for the quinoline type alkaloids. Okay, so these indole alkaloids, that one they do modified into the quinoline alkaloid. Okay, so here is the I have shown the how they do how the indole moiety that one is converted to the quinoline moiety. Okay, so some of the most remarkable examples of terpenoid indole alkaloids, modifications are to be found in the genus Cinchona Rubiaceae family in the alkaloid quinine, quinidine, cinchonidine, and cinchonine, long prize for their antimalarial properties. So all these things normally we use in as a antimalarial agent. The structures are remarkable in that indole nucleus is no longer present. It has been rearranged into the quinoline system. I have shown here. Okay, indole rearranged to quinoline system. The relationship was suspected quite early on, however, since the indole derivative cinchonamine was known to co-occur with these quinoline alkaloids. So here I am giving the structure of cinchonine and quinidine. Okay, cinchonine and quinidine. Most of the structure is similar, only the difference is R group. Okay, R group is here. So difference is here with R group here. So R is equal to, when R is equal to methoxy group, then structure is quinidine, and when R is equal to H, that means no substituents, then structure is cinchonine. Okay, so we'll see now the biosynthesis of this one. The outline of the pathway from the cornet type indole alkaloids to the cinchonidine. Again, the same thing we have to face here. What we have seen in case of yohimbine synthesis. So we have started from cornet type indole alkaloid to cinchonidine. So we are going to utilize the same thing what we have seen in the uh, not yohimbine but in synthesis of ajumelicin, so cornetha type. So here is a cornetha type, so this thing involved in the synthesis of quinidine and cinchonine also. So pay attention, cornetha type. The conversion is dependent on the reversible process by which amine plus aldehyde or ketones, imines, amine reduction products of imines are related in nature. Quinine and quinidine or cinchonidine and cinchonine are pair of diastereoisomers and have opposite chiralities at two centers, C8 and C9. Okay, so these are isomers. Quinidine, cinchonine, cinchonidine. They are isomers, diastereoisomers, and having chiralities at two centers, C8 and C9. The stereochemistry at C8 is easily reversed by tautomerism in cinchonidinone and cinchoninone as described. The stereochemistry adjacent to the quinoline ring C9 is controlled by the reduction stage. Okay, so all these things they are um, mm, isomers of each other. An enzyme catalyzing the reduction of cinchoninone produces an unequal mixture of cinchonine and cinchonidine, showing that the stereochemistry of reduction may somehow depend upon the substrate. Okay, so we can make changes in all these things by only reduction oxidation, and we can go for the biosynthesis of this on this molecule. So here is the pathway for the synthesis of cinchoninone or cinchonine and quinidine. Okay, so enzymes like NADPH. Okay, NADPH is it always helps for reduction. Okay, so reducing agent we can say naturally occurring reducing NADPH, and that way is transferring this hydrogen from NADPH to the our molecule. Okay, so here reduction of carbonyl group occurs with the help of NADPH. Okay, so reduction of carbonyl to alcohol occurs here. So as we have seen in on our early slide, that cornethial we are going to use as a precursor. Cornethial we do start synthesis of cinchonine and quinidine, having an intermediate this cornethial. Okay, so that one we have uh, took it from the streptocidin. Okay, streptocidin. On cycloserine on cyclization, it gives this intermediate. Hydrolysis and decarbonation use cormethial. Okay. Then cleavage of carbon nitrogen bond via iminium, then formation of new CN bond again via iminium. Okay, so here is we got cinchonaminyl. Okay, so cleavage of then indol CN bond cleavage, and subsequent then rearrangements it gives cinchonidinone and then cinchonidine, quinine, okay, like this. And cinchonidinone on epimerization at C8 via enol formation. Okay, epimerization at C8 at 8th carbon atom, and this cinchonidinone on reduction gives our cinchonin and quinidine. Cinchonin or quinidine. Okay, so both things are they are isomers of each other, ester isomers of each other. So this is the biosynthetic pathway for the synthesis of cinchonin and quinidine. Okay. So please go through that one, and for more things you can refer or the book Paul and Davy, that explains everything in detail.